So in this video, we are going to find the greatest common divisor of A numbers. So it is noted like this. We have two ways to find the GCD of a two numbers, which are listing and prime factorization. In listing method, it is a method that lists all the factors of a given number. While in prime factorization, it is a method that uses prime numbers to divide a number until no more divisions can be performed. We have properties in GCD. These are the GCD of A and A is equal to A, and the GCD of A and 0 is equal to A. The third property is GCD of A and B is equal to 1 even only if A and B are prime numbers. So, in example of the first property, which is GCD of A and A is equal to A, we have an example of if our A is 4 and 4, the GCD of them is also 4. In our next property, if the GCD of A and 0, their GCD is also A. For example, we have 3 and 0. The GCD is 3. And another example, if we have 25 and 0, the GCD is 25. In our third property, which is if the GCD of A and B is equal to 1, it means that A and B is prime or are prime. For example, 17 and 23. 17 and 23 is a prime numbers, so their GCD is equal to 1. And also 13 and 29. They are both prime numbers, so their GCD is equal to 1. Now let's have an example of using a listing method. For example, we are going to find the GCD of 4 and 8. So to find the GCD of 4 and 8, we will list all the possible factors of 4 and 8. So the possible factor of 4 is 1, 2, and 4. While in 8, we have 1, 2, 4, and 8. So they have common factor of 1, 2, and 4. We will choose the highest factor, which is 4. And that would be our GCD. Another example. Let's say we have a number of 15 and 30. So let's list the factor of 15, which are 1, 3, 5, and 15. While in 30, we have 1, 2, 3, 5, 6, 10, 15, and 30. They have a common factor of 1, 3, 5, and 15. And the highest factor of them, common factor of them is 15. That would be the GCD. Let's now have an example of weigh-in using prime factorization. Again, we have a number which is 4 and 8. Using prime factorization, we will perform a division of using a prime number. The least prime number is 2. So we will divide 4 into 2. So the answer is 4 divided by 2 is 2. And no more divisions can be performed, which will be 1, 2, and 1. While in 8, we can divide 8 into 2, which is the least prime number. So 8 divided by 2 is 4. And 4 can also be divided by 2. So 4 divided by 2 is 2 and 2. Now, let's denote the RGCDSD. So they have a common factor. We will get the last common prime factor of a 2 number, which is 2 and 2 here in 8 and 2 and 2 here in 4. Then 2 times 2, we will multiply the common factor, 2 times 2, which is 4. So that would be our GCD. So same with listing method, we get the same answer, which is 4. Let's have another example using prime factorization. We also find the GCD of 15 and 30. Using prime factorization, we will perform division using prime numbers. So in 15, we cannot divide 2 in 15, but we can divide 15 into 3. So 15 divided by 3 is 5. We cannot perform any division here, so we will go to 30. 30 can be divided by 3, which is also a prime number. So 30 divided by 3 is equal to 10, and 10 can also be divided by 2. So 10 divided by 2 is 5. No more divisions can be performed, so we will get the common factor or common prime factor on the both number. So their common prime factor is 5 and 3 here. Then 3 times 5 is equal to 15. And that would be our GCD. In here, we will tackle about kinds of prime numbers. The first one is relatively prime. The integers a and b are called relatively prime or coprime if a and b have greatest common divisor equal to 1. For example, we have 7 and 29 rather. Their GCD is equal to 1. Therefore, 7 and 29 are relatively prime. Another example, we have 11 and 13. Their GCD is also equal to 1, therefore 11 and 13 are relatively prime. Another kind of prime number is pairwise relatively prime. The integers a sub 1, a sub 2, a sub 3, up to a sub n are pairwise relatively prime if the GCD of 2 or more numbers is equal to 1. For example, we have a 3 numbers 7, 11, and 29. Their GCD is equal to 1. But when we combine 7 and 11, their GCD is equal to 1. And also 7 and 29, their GCD is also equal to 1. Same with 11 and 29. They are also equal, their GCD is also equal to 1. Therefore, 7, 11, and 29 are pairwise relatively prime. Another example in pairwise relatively prime is we have 11, 13, and 29. Their GCD is equal to 1. And 11, 13, the GCD of 11 and 13 is equal to 1. Same with 13 and 29, their GCD is equal to 1. Also with 11 and 29. Therefore, 11, 13, and 29 are pairwise relatively prime. The next kind of prime is mutually relatively prime. The integers a sub 1, a sub 2, a sub 3 up to a sub n are mutually relatively prime if the GCD of 3 or more numbers is equal to 1 and is not relatively prime. For example, we have 2, 3, and 6. Their GCD is equal to 1. But when we find the GCD of 2 and 3, their GCD is also equal to 1. But in 3 and 6, their GCD is equal to 3. Same with 2 and 6, their GCD is equal to 2. Therefore, 2, 3, and 6 is mutually relatively prime, and they are not relatively prime. Another example in mutually relatively prime is 5, 10, and 12. Their GCD is equal to 1. But when we find the GCD of 5 and 10, we can get the GCD of 5. Same with, or in 10 and 12, their GCD is equal to 2. And 5 and 12, their GCD is equal to 1. Therefore, 5, 10, and 12 are mutually relatively prime, and they are not relatively prime. And that's all. Thank you.